You can write it down if you want, but these are the main three things. Now, the first one is no radicands can have perfect nth powers as factors other than 1. Really what that's saying is that we can't leave it as, say, the square root of 4. Because the square root of 4 is 2. If a radical will reduce, we need to reduce it as far as possible. Because the same thing is true. We can't leave it as, say, the cubed root of 8. Or any of these powers. If it reduces, we have to reduce it. Second one, no radicands can contain fractions. We can't leave it as the square root of 1/2. We can't have a fraction inside of a radical, no matter what the root is. Because we can't leave it as the 6th root of 1/2. And the last one, radicals cannot appear in the denominator of a fraction. We can't leave it as 2 over the cubed root of 7. Radicals cannot be in the bottom of a fraction. A fraction can't be inside of a radical. And if a radical reduces, we need to reduce it. Okay? Now, our first core concept, properties of radicals. Product property. If I have two things being multiplied inside of a radical, I can rewrite it as the product of 2 or more radicals. Or we can go the other way. If I have a product of 2 or more radicals, we can rewrite it as a single radical. So the cubed root of 4 times the cubed root of 2, we can rewrite as 4 times 2, cubed root of 8. And it works out that the cubed root of 8 is 2. Quotient property. If I have something being divided inside of a radical, I can rewrite it as the division of those radicals, or go back the other way. We can combine them. Because the issue with this here is, 1, I can't have a radical in the bottom of a fraction. But when we combine them, the 4th root of 162 over 2, well, 162 divided by 2 is 81. And then we can simplify the 4th root of 81. And we need to use those kind of properties to be able to simplify these. Our first one is the cubed root of 12 times the cubed root of 18. Well, first thing we can look at is C. Cubed root of 12, cubed root of 18. Neither one of these is reducible. We could multiply those together and simplify from there. So we could rewrite this as, say, the cubed root of 12 times 18. And 12 times 18 is 216. Now at this point here, we can try taking the cubed root of 216, which we can. Another way we can look at it is the factor tree. Because if I factor 216, well, that'd be 2 and 108. 108 is 2 and 54. 54 is 2 and 27. 27 is 3 and 9. And 9 is 3 and 3. So 216 is 2 to the 3rd times 3 to the 3rd. And the reason that's important for us is because we're saying that we're taking the cubed root of 2 to the 3rd times 3 to the 3rd. Well, what is the cubed root of 2 to the 3rd power? Three and 3. So it is just 2. Cubed root of 3 to the 3rd is what? Because the exponent and the index are the same. We're essentially dividing the exponent by the index. 3 divided by 3 is 1. So it comes out completely. And 2 times 3 is? So 6 to the 3rd power is 216. The cubed root of 216 is, well, not 26. No, you can use a calculator on this. So we get 6. Let's look at the next one, the 5th root of 80 over the, not the 5th root, I need to change that. I'm saying that all day. 4th root of 80 over the 4th root of 5. Now, again, we could try this in a calculator, but if we look at this here, according to one of our properties, if we have two radicals with the same index being divided, I can rewrite it as 1 with those two being divided. Now, the main reason I would do this is because is 80 divisible by 5? Yeah, because 80 over 5 is what? 16. Because our main issue was having a radical in the bottom of the fraction. We can combine it, but we have a fraction inside the radical. But 80 divides by 5 gives us a nice number. I don't have a denominator, I don't have a bottom of a fraction, or a fraction inside the radical. Now we just need to see if we can take the 4th root of 16. And we can. And it is. So the 4th root of 80 over the 4th root of 5 is 2. Questions on this here? I mean, we could have broke 16 down into the fact that it is 2 to the 4th, and the 4th root of 2 to the 4th is 2, because when that index and the exponent are the same, they simplify out. Cubed root of 4 times the cubed root of 128. We can try. Cubed root of 4 is that. Yeah. Cubed root of 4 times cubed root of 128 is 8. So some of these work out nicely. And it would actually work out nicely on either one. 5th root of 192 over the 5th root of 6. And we could simplify this to the 5th root of 192 over 6. Well, 192 over 6 is 32. What's the 5th root of 32? Yeah. Questions on this here? Cubed root of 135. Well, we can try this in a calculator because that's been working nicely. Yes? Is?
Oh, it's 130.
Oh. Let's try that again. Well, that's not as nice. Okay. Now, if it doesn't work out nicely, we need to write this as simplest form. The best way, or one of the ways I've found to do this is going factor 3. Because we need a number to a power of 3, or some multiple of 3 to simplify with that root. So what are one of our factors or numbers that goes into 135? 5. It would be 5 times what? It would be 5 times, because we can just divide 135 by 5. Because 5 times 27 is 135. 5 is prime. What's one of our factors of 27? It would be 3 times. And 9 is 3 and 3. So 135 is 3 to the what? 1, 2, third times 5. And the reason that's helpful is, well, now I can replace 135 with its prime factorization. So it'd be 3 to the third times 5. Questions on how we got to this here? So, our next step, what is the third root? What is the third root of 3 to the third?
Okay, don't do that.
Third root.
18.
Nope. I can tell. Third root of 3 to the third. Yes.
Oh.
Because really all we're saying,
Oh, wait.
if we break this apart, we have the third root of 3 to the third times the third root of 5. So our first part's third root of 3 to the third.
I thought you were just talking about 3 to the third, not the...
The cubed root, third root of 3 to the third is 3. Can we take the third root of 5? No. So it stays third root of. So a simplified form of the cubed root of 135 is 3 times the third root of 5. And that's it. Questions on this here so far? Our next one, fifth root of 7 over the fifth root of 8. Now the issue with this here is that we have a radical in the bottom of the fraction. Now the fifth root of 7 is as simplified as it gets. Same with the fifth root of 8. Now the first thing we need to do in solving this here and simplifying this is determining if we can rewrite 8 as a number to a power or multiple numbers to a power. And if we're not sure, we can always factor tree. What's one of our factors of 8? 4 times 2. 2 is prime and 4 is? So 8 is 2 to the third. So we can put that there, 2 to the third. Because we want this in simplified form, it's going to be easier to work with. Okay. Questions on anything we've done so far? Now, that denominator, that fifth root, what would the power, the exponent attached to 2 need to be for it to reduce? 5, because if I had the fifth root of 2 to the fifth, it would reduce to 2, yes? How many 2's am I missing? Because how many do we have? How many do I need? We need 5, so I'm missing 2 2's. Now to do that, because we need 2 more, yes? So I'm going to multiply the bottom for sure by the fifth root of 2 to the what? 2, because we need a total of 5, so I'm going to multiply it by 2 more 2's, 2 squared. But if we do it on the bottom, we have to do it on top. Since we don't have an equation, we have to multiply the fractions on top and bottom. Now the denominator, the bottom of the fraction. Well, we have the fifth root, because we multiply them together. 2 to the third times 2 squared is 2 to the fifth power, yes? And what is the fifth root of 2 to the fifth? So the denominator is just 2. And that's what we need to do to simplify these radicals out of the bottom of the fraction. Now we rewrite it as 2 to the third to make sure we don't put too many. Now the top, we're going to multiply 2. Now up here, fifth root of 2 squared. Can we reduce that nicely? No, because the power is not big enough, yes? Can we reduce the fifth root of 7? Well, no, right? So is it possible to reduce the fifth root of 7 times 2 squared? Well, if one part doesn't work and the other part doesn't work, is there any way combining it is going to make it work? No, because we don't have enough factors between the two to make it reduce. So we're just going to leave it for the most part. But I'm not going to leave it as 7 times 2 squared. Because what is 7 times 2 squared? Yep. And that's it. So we need to multiply the top and bottom of this by a certain amount so that the radical on bottom simplifies out. Does that make sense? Would you all agree that this is simply complex? It's complex and simple all at the same time. And I hate that it does that because there's so many things in math that go hand in hand that way. But again, if the radical is not reducing, especially the calculator doesn't give you the answer, break it down into primes, prime numbers, 2, 3, 5, 7, any of these primes, and take the cubed root of each one, or the fifth root, or the root that we want, and then go from there. Now, what you multiply top and bottom by, what we did here, the power inside that radical will never be bigger than the index. So for this here, the 2, the exponent of 2, that exponent that we put there, we cannot put one bigger than 5. Because if I said 2 to the 5th, well, that reduces already. We're too much. Does that make sense? And we always want to go to the next set. So if it was inside there was 2 to the 6th, we're taking the 5th root of 2 to the 6th, we're going to go to the next set of 5, which is 10. And we go up. We don't want to go down. Cubed root of 500. Well, that's probably not going to work out nicely. So let's factor tree 500. What's it? Huh? So we can say 2 times 250. Factor of 250. We can keep with 2 and 125. Does 2 go into 125? No, but 5, 6. Yeah, and that would be 5 and 25. 25 is 5 and. So these are all primes. Yep. So we have 5 cubed times 2 squared. And luckily, the factor tree calculator will help you with this for the most part. So the cubed root of 500 is the same as 2 squared times 5 to the 3rd. And we can look at our first term. What's the cubed root of 2 squared?
4, 6.
Can we reduce it? No, because the index or the exponent's not big enough. It had been 4, we could take 1, 2 out and 1 would stay in. But here, it doesn't reduce at all. So our 2 squared would stay inside, and we could just rewrite it as 4. 5 cubed. What's the cubed root of 5 to the 3rd? 5. All of them are going out. So we're left with is 5 times the cubed root of 4. That's it. Because we can simplify the cubed root of 5 to the 3rd. We cannot simplify the cubed root of 2 squared. Cubed root of 5 to the 3rd is 5. Cubed root of 2 squared is just the cubed root of 4. You're right. 19 won't divide by 4, so we can't do like previously as one radical and divide and go from there. So what we're looking for is something to multiply the top and bottom of this by so that the radical in the bottom of this fraction will reduce, will disappear. Now, it's very tempting to say 4 cubed, but that's going to be a little too big. Because can we rewrite 4 as a number to a power? And it is. We can rewrite 4 as 2 squared, because 2 squared is indeed 4. We feel comfortable with saying that there. How many 2's am I missing? 2. So we can multiply the top and bottom by 2 squared. Now the denominator is going to become the 4th root of 2 to the 4th, which is just 2. The top is going to be the 4th root of 19 times 2 squared. Now the top, 19 times 2 squared is what? Is 76. Now the only way the numerator would reduce is if we had, in this case, factors of 2. So if 4 was a factor of the other top, of the top that we began with, then it would reduce. Yes. But if that was the case, we would have been able to divide at the beginning. Questions on these here? Are you ready for what's next? We want to write this in simplest form, 1 over 5 plus the square root of 3. Now to do that, we need to get the radical out of the bottom of the fraction. And there's one main way to do that. And we have to multiply the top and bottom of this by its conjugate of the denominator, which is 5 minus the square root of 3. Because the conjugate, complex conjugate, irrational conjugate, we just changed the sign between them. Term or complex conjugate, you change the sign in front of I. Now, out of the top and bottom, the numerator is nice. Because if I multiply 5 minus the square root of 3 by 1, 5 minus square root of 3. Now the denominator, we're going to distribute. 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. Square root of 3 times positive 5 is plus 5 square root of 3. And lastly, square root of 3 times negative square root of 3 is negative square root of 9. Questions on this so far? So the whole goal was to get the radicals out of the bottom of the fraction, yes? And by multiplying it, we ended up with actually 3 radicals, not 1. We went from 1 to 3, yes? But let's look at it. Well, top is still 5 minus square root of 3. 25. Oh, wait a minute. Isn't negative 5 square root of 3 and 5 square root of 3 like terms? 0. That is 0. So those are gone. Okay, that's nice. What is the square root of 9? So we actually have no radicals in the bottom of the fraction. That's what's nice about that. It removes all the radicals from this. Now what is 25 minus 3? Questions on this here? So we can check our answer because we had that before. Yes. Because we can plug it in, check the decimals, make sure the decimals line up. And if they do, then we have the same thing. Was it 5, not minus, plus the square root of 3. Enter, and we get...
Oh, we could just enter that in the calculator?
Yep. But it has to be in the 30XS. The yellow calculator. The graphing calculator will give you a decimal every single time. Yep. Questions on this here? Because even if we 4 over the square root of 2 minus 5 square root of 3, it gives us to it. That's the answer. And that's it. 14, 15, 18, 20, 22 through 28, even 31 through 34.